look at the solution to question 6. The question reads: find W0, W1, W2, which are the 3 roots of unity. Show that W1 square is equal to, show that 1 plus W1 plus W1 square is equal to 0. Okay, so this is the question we will tackle in this tutorial. So let's let me note something's down. So we are going to show that, so W1 square is equal to W2, and we are going to show that 1 plus W1 plus W1 square is equal to 0. So this the tasks we've been given. So let's see how we'll do it. Okay, so this is a problem from the roots of unity. In fact, this is the nth root of unity in our case. So in our case, n is 3. Let me check the question once again. Show that, find this, which are the 3 roots of unity. So we are dealing with the 3 roots of what? Unity. Okay, so we know that W, since W is a root of unity, we know that W to the power 3 is equal to 1. We know this. And if W to the power 3 is equal to 1, we can write it in polar form. Or W to the power 3 will be what? Cos 0 plus I sine 0. And this will lead us to W. So let me write it in a standard argument form. So in the standard argument form, we say that Wk, where k is the root, is equal to what? Is equal to, so since this is unity, that means, so in general form for all complex numbers is what? Nth root of r multiplying cos of theta plus 2 pi k over n plus I sine of theta plus 2 pi k over n. In this case, r, which is the what? The length of our complex number. So r is equal to 1, and k and n, let me write n first. N is equal to 3, and k is equal to 0, 1, 2. So k starts from 0 up to what? N minus 1. So in our case, 3 minus 1, which means it will k will stop at what? 2. Okay, and our theta is equal to 0. If we write this complex number in the polar form, we have cos 0 plus I sine 0 so that means our theta is what? 0. So we can write our formula WK is equal to what? So here the R, our R to be 1, n root of 1 is still 1, so we don't need it anymore, so we can just quote this part, cos of our theta is 0, so 2 pi k over n plus I sine 2 pi k over n. So at k is equal to 0, W naught will be equal to cos of 2 pi times 0 will give us 0 over our n, which is 3. So we have 0 over 3 plus I sine 0 over 3. We know that 0 over 3 is what? Is 0. So W naught we call the cos 0 is 1 plus sine 0, I sine 0, sine 0 is 0, I times 0 is 0, so which is 1. So we know that W naught is equal to what? 1. So we have the first root. So now let's look at the case where k is equal to, so where k is equal to 1. Some space, and we cancel this part. So at k is equal to 1, we have our W1 is equal to cos of 2 pi k, that means 2 pi over what? 3, because k is 1, so 2 pi times 1 will just give us what? 2 pi plus I sine 2 pi over 3. So our W1 will be equal to cos 2 pi over 3 plus I sine 2 pi over 3. Okay, so the final one is W2. So W2 will be equal to cos of 2 pi k, so 2 pi times 2, which is 4 pi over 3 plus I sine 4 pi over 3. But remember that we usually leave our answer in what? The principal argument form. So W2 will be equal to, so if we want to change the 4 pi over 3 into principal argument, we do what? We subtract 2 pi from it. We have 4 pi over 3 minus what? 2 pi. So this is the same as 4 pi over 3 minus 2 pi. So this over 1 times 3 is 6 pi over the 1 times 3 is 3. So 4 pi minus 6 pi is minus 2 pi over 3. So in what? Principal argument form. In principal argument form. So we now have it as what? Cos of minus 2 pi over 3 plus I sine of, I just have to cancel, wipe out some place, so let me deal with this part. But let me not forget that our W0 is equal to 1. Where is our W1? Where is W1? W1 is here. W1 is here. I need the answers. Okay, so I'll make up more space. If you want, you can replay the video and check out that which I have cancelled. So let me note my answers here and just cancel everything. And note my W0, W0, W1 down. So 1, W0 is equal to 1. W1 is equal to, let me write it here. So 2, W1 is equal to cos 2 pi over 3 plus I sine 2 pi over 3. If you want, you can pause and replay it and check where I've cancelled so that you won't be missed out. But if you are following, let's continue. Okay, so plus sine of I sine minus 2 pi over 3. This will lead us to W2 being what? We know that cos is what? An even function. So cos of minus 2, so cos of negative theta is equal to cos of positive theta, because cos is what? An even function. So this is the same thing. So cos of what? 2 pi over 3 plus I sine, and sine is what? An odd function. So if I have sine of negative theta, is the same as negative sine of theta. Is that fine? So that means that our positive here, the plus there will be what? Cancelled and change to what? Minus. So minus sine of 2 pi over 3. So now we have our third root, which is W2 is equal to what? Cos of 2 pi over 3 minus I sine 2 pi over 3. That's perfect. So now let's revise the question and check what we wanted. First, we were asked to check whether W1 square is equal to W2. So let's quickly check it. W1 square is equal to what? Cos of what? 2 pi over 3 plus I sine of 2 pi over 3 all square. So by applying De Moivre's theorem, if we apply De Moivre's theorem, we know that cos theta plus I sine theta all square is equal to what? Cos all to the power n. Let me use n. All to the power n is equal to cos. So we multiply the theta by n. So cos n theta. So let me put it in bracket. Plus I sine n theta. And put n theta in brackets. Let me just make up more space so that I'll write it clearly for you to visualize it well. So let me deal with cancel all these guys. I have them, so let me just carve out the empty space. So let me write it well here. So De Moivre's theorem states that cos theta plus I sine of theta all to the power n is equal to cos of n theta, so we multiply the n by the theta plus what, I sine of n theta. So apply the same law or theorem here. So this means that our W1 square, we are applying the Morpheus theorem to this guy, will be what? Will be equal to cos of 2 times 2 pi. So that this 2 is the square we are seeing here. So the 2 is now our n. So 2 times 2 pi over 3 plus I sine of 2 times 2 pi over 3. So W1 square will be equal to cos of 2 times 2 pi, this over 1, so 2 times 2 pi is 4 pi over 3 plus I sine of 4 pi over 3. But we, as I stated initially, that we leave our answers in the what? In the principal argument form. So we change the 4 pi over 3 to the principal argument by what? By subtracting 2 pi from it. Why are we subtracting 2 pi? Because the periodic of, or the periods of cos and then sine functions, the period of cos and sine function is what? 2 pi. So we are subtracting the 2 pi from this guy to have our answer, which is what? Because let me tell you the range for this theta. In principal argument form, we shall have it in this form: negative pi less than or equal to theta less than pi, or less than or equal to pi, or some people will also write it negative pi less than theta less than or equal to pi. Anyway, so if we subtract 2 pi, we get what? Minus 2 pi over 3. So our W1 square will be equal to cos of, you know that cos is an odd function, so an even function, so both negative and positive will still be the same. So 2 pi over 3. So the negative will affect sign because it is what? An odd function. So we have minus I sine 2 pi over 3, and this is the same as what? Our W2. So hence we've shown that W1 square is equal to what? W2. So that means if we square the second root, that's W1, if we square it, we'll get what? The third root, that's W2. So now let's check the final part of our question, which is if we add all the roots, because this one here represents W0, so W0 plus W1 plus W2, which will get to a 0. W2 is the same as W1 square. So 1 plus, or W1 is cos of 2 pi over 3 plus our W2 is we haven't finished with the W1. W1 is cos of 2 pi over 3 plus I sine 2 pi over 3 plus W1 square, we just computed it here, which is what? Cos of 2 pi over 3 minus I sine of 2 pi over 3 and this is equal to, see, this is positive I sine 2 pi over 3 minus I sine 2 pi over 3, so this will give you 0, and cos 2 pi over 3 plus, so plus cos 2 pi over 3 will give you 2 cos 2 pi over 3 is just 2, and then so 1 plus 2 cos 2 pi over 3. So if you change your calculator into radiant mode and you press cos 2 pi over 3, you'll get negative half. So you have 1 minus 1 plus 2 multiply minus 1 over 2 minus 1, which is equal to 0. So we've shown that if we add 1 plus w1 plus w1 square, that's, in other words, w0 plus w1 plus w2, we will get what? 0. This is actually a property of complex numbers, of the nth root of a complex number. If you add all the roots of a complex number, you get 0. So we are just asked, we've been asked what? To check out that property, and we've shown that that property is actually true. So if you have any problem, or if you don't understand anything from this, I might not be the best person to do it here. Maybe you can let me know, so that I will see how best I can handle your problems, how best I will help you out from your problems. So maybe if this is not the best solution that you are looking for, let me know, so that I'll see how I'll change my styles to meet your demands. Thank you very much once again. So let's check the question, whether we've been able to tackle everything in that question. And yes, we are done, or we are through with the question. So in our next video, we'll look at the 7th question. So little by little, we'll finish the entire paper. Thank you very much once again for your time. Please, if you haven't subscribed, consider subscribing to the channel. See you in the next video.